Hey everyone, my name is Finalizing from Berry Science Lab, and today I'm going to be talking about a very nice problem from the textbook Putnam and Beyond by Professor Titu Andrescu. And I'm covering this because even though it's the first exercise of the first chapter, it was still surprisingly hard for me to get through. So, let's start. We have to prove that this number is irrational. Okay, so how do we do that? Well, we start by, this is a proof by contradiction because, it comes from the chapter titled Proof by Contradiction. So proof by contradiction. Assume the square root of 2 plus the square root of 3 plus the square root of 5 is equal to some number a divided by b, where their greatest common divisor is 1, and actually I think it's the greatest common factor, and a and b are integers. Okay, so how do we show this is false? Well, first, we subtract rad 5 from both sides. And then we square. What happens when we square? Well, you get the square root of 2 squared is 2, square root of 3 squared is 3, then the product is rad 6 multiplied by 2. That's equal to this squared is a squared over b squared, minus, this becomes plus 5, and then their product is minus 2 rad 5 a over b. And now we're enabled to multiply both sides here by b squared. But first you might notice this is 5, and that's also 5. So we cancel them out. Now we multiply both sides by b squared. And we get 2 rad 6 b squared is equal to a squared minus 2 rad 5a b. Now we bring this to the other side, and suddenly we have a squared minus, or we can write plus, minus 2 rad 5b a minus, can write plus minus 2 rad 6 b squared. That's right, this is a quadratic equation of a. And if you flip things around, it's actually a quadratic equation of b, but that's less useful. So now, that means we can actually solve for a in terms of b. So we take a is equal to minus b, which is minus this coefficient, 2 rad 5b, plus minus the square root of this squared, which is 2 squared is 10. No, wait, 2 squared is 4. The square root of 5 squared is 20. Oh, wait. 2 squared is 4. The square root of 5 squared is 5. This makes their product 20. So you have 20 b squared. And then minus 4a is 1. And c is minus 2 rad 6. So you actually get 20b squared plus 8 rad 6b squared divided by 2. So now first you cancel out all the factors of 2 you see. This disappears, and you can factor out 4 from here. This becomes 5, and this becomes 2. And in fact, you can also factor out b from here, because if you look closely enough, this is b, and the b squared factor from under the square root all reduces to a factor of b that you can take out. Which means that we have a over b is equal to the square root of 5 plus minus the square root of 5 plus 2 rad 6 from our quadratic equation. Now, we already assumed that a over b was rad 2 plus rad 3 plus rad 5. Now we cancel out the 5 from both sides, and we get the square root of 2 plus the square root of 3 is, we disregard the negative root because two positive numbers can't add to a negative. Wait a goddamn second. Wait, so my manipulation from earlier. Hey, Liz. Okay. So is it really trickier than I thought? Reduce it through that method? Let's see. Yeah, because the square root of 2 plus the square root of 3 squared is obviously just 5 plus 2 rad 6. So what's going on here? Why doesn't this method work? Well, it just gives you back the same thing you were supposed to get. And you might say, well, can't you just assume since this is rational, this is irrational, and this is irrational, then all of these three, since all of these three are rational, can't you assume that their sum is irrational and just say that works? Well, no, because pi is irrational, 4 minus pi is irrational, and yet their sum is not just rational, it's an integer. So, you can't show, well, there's one more trick I can try. Now, this is rational, we assume that. That means that if you subtract 2 rad 5 from this obviously has to be irrational, right? So you get the square root of 2 plus the square root of 3 plus the square root of 5 multiplied by the square root of 2 plus the square root of 3 minus the square root of 5. And this is difference of squares. Combining it together, this gives you 5 plus 2 rad 6 minus 5, which is just 2 rad 6 on this end. And what's up with this end? Well, you get a squared over b squared minus 2 rad 5 a over b. Now, it might look like we're just retracing our steps from the 2 rad 6 b squared is equal to a squared minus 2 rad 5 ab, but I think we can actually pull off something a little bit deeper than that here. So, this is irrational. Wait, so how can we use that to justify? Let's see. So we have a squared over b squared, a squared over 2b squared minus rad 5 a over b is equal to 2 rad 6. Oh, sorry, rad 6. So now you get the square root of 6 plus a over b rad 5 should be equal to a squared over b squared. So what does that imply? Well, but that's already known to us. So what can we say here? Well, we can't just make this a quadratic equation and then solve for n, right? Because that would just give us back what we plugged in, at least hypothetically. But it's not just hypothetically, it actually gave us back what we plugged in. So, what can we do? Sure, this argument is on the precipice of working, but it's just on the cusp. Okay. So, why wouldn't this work? Okay, so let's multiply both sides by 2b squared. You get 2b squared rad 6 plus 2ab rad 5 is equal to a squared. So what does that mean? Well, this, which is irrational, and this, which is also irrational, have to somehow add up to give us an integer. And not, oh, wait a second, there's a huge, it's staring me right in the face. This is divisible by b, because you have a b here and a b right there. But our presumption was that a and b were co-prime. So you get a over b is sudden. So you get that since a squared has b as a factor buried in here, that implies that a is also divisible by b. Well, since a squared is divisible by b, that means a must also be divisible by b, and the only case where that's not true would make b divisible by a instead. So, this contradicts itself because it forces us to have an expression where a is equal to b times some integer, which means that it can't be true. So that's it. Thank you everybody for watching.